So I'm Nathan Fischer. At my previous job, I was evaluating which build tools to use for a new Scala code base, and Mill was kind of one of the new up-and-coming options. It didn't have any plugins for Docker, building Docker images from your code, or for doing Flyway migrations, and I went and gave it a try to implement those plugins myself, and it was shockingly easy, and I've contributed them since to the core Mill project. And so we'll talk today a little bit about the Mill build tool and how you can extend its functionality. So just for warm-ups, what does a Mill build file actually look like? It's pretty simple. It's just a Scala object. That's really all it is. It uses inheritance with a Scala module, which is something that's built into Mill, and it provides you fields that module is going to need in order to make your build actually work, like which version of Scala you want to use. It's not limited to Scala. You can also have a Java module or just a plain module or implement a module for any other language. And the build is introspectable, so you can kind of run it on the command line and say, hey, show me where the source code lives. And you can see, it lives under the foo directory in the source folder. So the name of the Mill module object defines the namespace on the file system for where it's expecting things within that module to live. Also worth noting that Mill has a default background server running for all of its builds. So unlike SPT, it's not going to reevaluate every time you run something through the command line. It's very fast. So how do we add functionality to our Mill build? Well, we just write plain Scala code. In this, we're going to build a little task that's going to count how many lines of code we have in our file. So I added a simple hello world file into our source code directory. And we can kind of see it'll run, it'll walk the path, and it'll print the line telling us how many lines of code there are. You can also have non-task Scala methods, so just actually plain Scala. So I've added just a location or a lines of code helper here that is not a task, and this T with the bracket we see is what denotes that something is a task. And that task, as we'll see later, gives us caching and all kinds of other good stuff. So if we actually run our lines of code task, we can see, okay, there's 6 lines of code in our hello world file, and it prints out, that we're counting the number of lines of code. So what is a task? It basically has inputs within the build. So inputs are other tasks that get called and can be cached, and it can have parameters to the method that makes up the task. It can also have outputs within the build, so it can have a return value just in straight Scala. The hash code of that return value is used for caching to determine if the task is changed, basically. And interestingly, the output of the task, both the Scala value and the hash code of the inputs are written to disk as JSON. And I think that opens up a lot of interesting tooling opportunities where we can have non-Mill tools look at the output of the Mill build and know things about the build, like where the source code files are, where the binary outputs are, things like that, without actually even needing to run Mill itself, as long as someone's run it before and has the outputs on the disk. So those things within the build are what are cached, and then outside of the build, you can have inputs like environment variables, things on the file system, things on the network, all your other side effects, and likewise, all those things can also be outputs of the build. So if you're running a Flyway module, it's going to run a database migration, and that's going to be external to the build. So there's 7 different types of tasks, and they all basically implement the task functionality differently. I'll run through them all pretty quickly, but they basically deal with how things are cached, whether they have input parameters, and whether or not you can call them from the command line. So targets are kind of the default type. The return value is cached to the disk, and if the inputs haven't changed, then the target simply isn't re-executed. It'll just read the JSON off the disk to rebuild the Scala object and feed it to the downstream task that's using this task. and you can run it from the CLI. Commands are similar. They can have parameters. They always execute, so they're never cached. The return value isn't read from the disk because it's always run, so you don't need to define any JSON deserializer for it. Inputs are similar to commands. They run every time they're called, and inputs are quite smart. All the tasks are smart, but inputs are a really good example in particular, because even though they are reevaluated each time you run, it still compares the hash code of the output to the hash code of the previous execution, and if it sees that there's no difference, it's not going to trigger a downstream cascading execution of any other tasks that use that input. So an example would be if you are reading the hash code of a Docker image that you're using as the base image for a build, and you use an input to call the Docker command to get that hash code, it's going to see, oh, the hash code is the same as last time. I don't need to rerun this Docker build because nothing has changed unless the source code has changed. And so that can save you a lot of time when you're just running through big cache executions in CI and things like that. Sources are basically inputs, except with some functionality added on top, so they deal with directories and files. So sources, you just give it a list of file paths, and it'll go and hash all the files inside of that path, basically build a Merkle tree of those, so you can tell if any of the files have changed in those directories. So like Scala already is going to give you incremental compiles, but if you have like protobufs or something like that, and that's part of your build, and you want to generate Scala code from the protos, you can look and see, okay, have any of these proto definitions actually changed, and do we need to rerun Scala PB or whatever uses you have. Anonymous tasks, these you don't use as much, but they're basically like a task, and I mentioned at the beginning you can have just plain Scala methods. The only downside of a plain Scala method is it cannot call tasks because it's not part of the caching system. So an anonymous task basically lets you elevate that method into something that can call other tasks and participate in caching. So persistent targets, these basically carry state from execution to execution. So you can do your own caching with them. Essentially, you tell Mill, hey, don't reset my output directory in between runs. Workers are similar to persistent targets, but rather than having their state be on the disk, it's in memory. So you can have these for short-lived caches. So it's a great place to do something like vault credentials, where you want to connect to an external service, grab some credentials for the session or whatever, but you want that to go away at the end of the mill build process. Okay, so how do we actually elevate a task into a plugin? So it's pretty simple. We can pull our lines of code task out of our simple dummy module and put it into a trait instead of an object. And we'll have it extend a Java module rather than a Scala module, because we can count the number of lines of code in Java just as well. All we care about is that we have this sources task that it's calling, and that sources task means that we have some source code directories, which is not a given for just a naked base module. So you can take your trait, and then you can make any other module extend the lines of code module, and you'll have the ability to call lines of code on your module. So I went ahead and did that, pulled it out into its own file, and I imported that file into the build of Mill itself. So Mill has a main module in its build, and we can make that extend the lines of code module and say, hey, how many lines of code are in the main Mill module? And it's 769. So just with something as simple as that, pulling this straightforward Scala method out into a trait and extending that trait somewhere else, we've got ourselves a plugin. So the import syntax for that plugin is familiar if you've used Ammonite before for Scala scripting. You can import any Scala script into a Mill build, and then you can use all the Scala code inside of it. The other way you can do is you can build it into a jar and publish it up to Maven Central. So if you want to do this external to your company or something like that, that's a great way to go open source with it. So onto kind of a more real-world plugin, the Docker module. Most of the information we need to get a Docker module is, available in the mill build, or we can kind of default it to an empty list or an empty string or something like that. The ones we definitely want are the tags. So by default, we can say we want to tag our Docker image with the name of the object that we use to define our module. We want a base image. So, what are we building this off of? So Google's distro list Java makes it a passable one. And we want to know whether or not we should repull the base image. And Docker tags are not tied to one specific version. You can update the version underneath. So this basically gives us an option to say, hey, every time go back and check on the remote Docker repository if the base image has changed and rerun the build if it has. And there's a bunch of other ways that we can customize the build, of course, but these are kind of the core ones. And again, the Docker module really is just this collection of tasks that you're going to be able to inherit inside of whatever module you want to build a Docker image out of. So I'll get to actually building the Docker image later, but I think as far as illustrating mill and its caching, one of the most interesting tasks is this cache buster that is not something you see on the outside of the module, but internally it basically deals with that task that says, hey, should we pull the base image? And if it does, we need a way to tell the caching system, hey, rerun the build because pull base image returns true and you cache true and it'll see that it was true last time and the caching system will just kind of skip the rest of the build. So what it does here is it basically goes ahead and says, if we're supposed to be pulling the base image, generate a random number. That random number is going to generate a different hash code from the last run, and it's basically going to make sure that mill busts that cache. And we can see here the JSON value of the base image cache buster, which is this tuple of true, yes, let's pull the base image, and our random value. And then the input hash and the output hash, which I had mentioned previously. So that JSON object really is the output of every single task in mill. So then on to actually building. There's a few different tasks that we call from inside of here. One is the assembly task. That's built into our JVM things, and we say, let's build a bunch of class files and wrap them all up. The base image cache buster that we just saw, and the Docker file, which I won't show, it's a bit long to fit on a slide, but if you've ever written a Docker file, it's the same thing. The Docker file task just returns us a string, which is the content of the Docker file. And then that string also, likewise, is written to JSON as well as written to a file in this task. It uses the OS lib, or mill uses the OS lib by default, but you can use any, file system interacting library, the one from Java or whatever floats your boat. But the OS lib is fairly straightforward, and it's good at passing inputs and outputs through the lower level mill server up to the mill executable that actually you invoke from the command line. And at the end of this, it returns the built tags of your image. So again, if you had something you wanted to call this from the command line, you wanted to inspect the JSON, you'll know the image you've got with the tags it was tagged with, so you can go pipe that elsewhere into your CI pipeline to do whatever. Of course, after you've built it, you want to push it up to Docker Hub. That one's pretty straightforward. From our push, we want to make sure that it's built first. And then it goes through each of those tags and goes ahead and calls Docker push on them. You can see there's a separate task for the executable, so if you're on Podman on Mac or something like that, you can customize which executable you're using to access Docker. Mill is also introspectable, so you can run something like visualize plan, and it'll show you each task that's getting run and all the tasks that that task calls and so on and so forth. So if you want to speed up your build, this is a great way to do it. I've kind of cut off the bottom little corner here, which goes into building an entire image, but this is the directed acyclic graph of the build that we had at Lightform for our backend platform. So the takeaway I ultimately want to give you is that if you look at mill and you're like, oh, should we try and give this a go? Don't let the lack of an existing plugin scare you away. Go ahead and say, oh, well, could I have written myself that plugin in Scala? And if the answer is yes, you probably can turn it into a mill build very easily and open source it out to the rest of the community. So yeah, that's the gist of what I've got. I'll kind of open it up to questions. Yes, absolutely. Yeah.
I'll repeat the question. Was there a mechanism for pulling from Maven Central your dependencies?
Yes. Ooh, we're echoing off each other a bit. There is a way to pull dependencies off Maven Central. You can do it both for Java dependencies or Scala dependencies with the Scala version getting resolved. I didn't show it because I'm mostly focusing on the tasks, but it's a similar syntax to SVT where you've got 2 colons if it's a Scala dependency and 1 if it's a Java dependency and 3 if it's Scala JS or something like that.
Yeah. And are there any other languages other than on the JVM that have any level of maturity that you've seen Mel used for?
I haven't. I've run some web builds myself on it, but I haven't seen open source modules running those, but I haven't looked too hard. Any other questions? All right.